general explanation about the CPDLC communication standard. Yesterday we had a session. So in the DFS, it's planned to have it implemented in the lower airspace as well. So that's why we had a meeting yesterday with them to discuss, okay, how will be the implementation in the lower airspace. We are using CPDLC for a long time already. It was one enabler as well from Favorit, from the system. It was one of the next steps to be implemented. And it's now online for a long time already. To give you some numbers, because yesterday we had some numbers on the table. They are not here in the presentation. But we have a couple of data sets to be exchanged with the pilots. And in 1 month, we had 250,000 frequency changes done in Karlsruhe alone with data link. Just to give you a number. How many times it is clicked.
So frequency change is the most popular one?
Yeah.
And even the levels.
So on the aircraft is the equipment.
Juliet 1 equipment.
So that last sentence is the important one. So we are using only the ATN system VDL mode 2. This is what we offer. The fans is also available on the market, mostly in the US and transatlantic. But this is what we are supporting. So in addition to that, we have a so-called whitelist online, which is filtering out some airframes which are always producing problems in the network. For example, the 777s from the Boeing, they had problems in the software, in the cockpit software, and they were producing some problems in our network. So the whole network slowed down. So that's why we excluded them to be able to log in our system, our CPDLC system. So they are excluded. We have a number like 80% of all the airframes flying around, a little bit more than 80%, are on that list. So they can log in our system. We as an ATCO here, we only show if a pilot has successfully logged in. Then you have a certain item as a target that tells you as an ATCO, okay, I'm now able to transmit messages with that cockpit without voice. So this is all done automatically. The symbol we have used is this one here. So instead of the normal black one, it's like that square, and that shows you, okay, he is now logged on. That will enable in the menus certain fields to be triggered to exchange that with the cockpit.
Different execute buttons, because then we provide execute RT or execute data link.
There are most two suppliers in Europe.
Yes.
Which supplier?
Sita and Collins. Yes.
Collins was airing before. Collins.
Yeah.
Now you
Sita and Collins both.
These are the two.
We signed the contract to Sita and Collins.
Yeah, correct. And Collins was a time ago. He was called Eric.
So there are certain preconditions which are mandatory. So in the flight plan, for example, you have to file that Juliet 1 to be able to fly here. It's important to know that in European airspace, it's like you log on somewhere in Europe where you are allowed to log in, and then the units making that forward of that login. So the pilot has once to log in, and then automatically this is extended to the other external partners. So that's how it works. It works to a certain altitude. So in upper airspace, it's very popular. If you get to lower airspace, at a certain point, it's disconnected. But I think that's valid everywhere in the world. Yeah, so there are some flight plan preconditions. That's about the log-on list, which is also hosted by the Maastricht colleagues in France and in Switzerland, for example. It's not everywhere online, but here in the very dense traffic areas, it's very important to have a very stable network and system, so that the ATCO can really rely on a quick response from the aircraft and no delay in the network.
So if you want to buy an aircraft, don't forget to put it on the list.
So, because the controller is prefer to use the CPDLC than VHF.
Yes, absolutely.
Yeah.
It's nowadays, especially if you have newer aircraft. Let's take the Airbus 350-900. The cockpit wise, the whole HMI and the cockpit is such good and fast that the reply is like a verbal call from ATC to the ground. So they answer in seconds. You know, you send climb 350, it makes a noise in their cockpit. They say yes, one click, we get the answer. It's faster. You can even do it talking to another aircraft, and meanwhile clicking a button and sending away another aircraft.
Like
So
below 10 seconds on the time.
the average time is 10 seconds. Yes.
Can you tell us about the experience? How to define the demand, your demand to use the CPDLC?
Around 70% already. Yeah?
Yes, between 65 and 70% are locked on.
No, I mean when you have a plan to use the CPDLC, how to define the need, your need? Yeah.
Do you mean how to convince the people to use CPDLC in the end? So for us, it's a capacity.
Or when
question.
when do we use it?
No, why you choose the CPDLC for communication?
Okay, yeah, but
Easier,
it gives
faster.
it's faster. So to exchange 6-digit numbers and frequencies via voice always have the risk that something is wrongly
6 digits
understood.
for the
And just to send it as a ticket, you know, as a ticket to the cockpit is
Die Frage ist,
simply
die Frage ist,
faster and safe.
Any challenge when you use the VHF? So you decide you must use the.
Okay, there's no must. It's optional. There's no must. You can always go to RT. It's always your primary option. As a secondary option, you can always go to CPDLC.
so
But
as,
if you have a combined clearance, for example, you know, CPDLC works only in steps. You can send him a level, you can send him a direct, for example, but not two in one step. Then they are two lines of transmission.
let's,
And if you want to have a complex clearance and you want to issue it to the pilot, then you in many cases use voice. But if you have only one of them, or it doesn't matter about the time, then you click one by one.
yeah, let's jump into the environment, Kong. Let's jump into the environment. So you may have an issue, Kong. You may have an issue. The issue could be like in Europe that the new bottleneck is spectrum, right? So frequencies are crowded, and therefore CPDLC very much contributes to relief for the spectrum. Yeah, that's good. It's less workload for the controller. He needs to speak not that much as before, right? But your specific environment where you lack of coverage of VHF, so you have areas where you do not have coverage. Yeah, this could be a very strong argument for implementing CPDLC just to ensure communication, which is not RT, but then based on this data link, right? So this is your idea. So for here, we do not have a regulatory requirement. It's not a must, as Ole said, huh? But we do have some motivation. Yeah. The spectrum is crowded, so this is the new bottleneck here. So we need to take some measures in advance. So we want to be before the power curve, before everything goes down, right? Or we want to relieve the controller. In your case, it would be I need to disseminate or pass on a message, and I do not have VHF coverage, right? So it's a strong argument, yeah. And there it could be a must. In your specific environment, it could be a must, yeah. Okay, here it is not. Huh?
Even though it depends on antennas on the ground, but the new technology is via satellite.
Yeah.
So the SATCOM. So we had trials last year. The first flights equipped with SATCOM. And it proved to be really fast and good, but still very expensive. Still very expensive.
Yeah.
But this is of
That's
course
a
the
good point,
future,
huh?
because then you don't rely on any antennas on the ground. it's via Satcom satellite, so you have always a good connection, even to lower altitudes. That's very important. So that will be for sure the future.
Yeah, when we provide internet in on the plane, you must use Satcom.
I've been to Africa and I talked to an African colleague and he said we have implemented CPDLC all over from flight level 2, 4, 5 and it's 100% used for security reasons. And I said, excuse me, that's super interesting and impressive, but for security reasons? And he said, yes, we have so many rebels on ground and they are constantly attacking our infrastructure, ground-based infrastructure, be it antennas or what it is, yeah, or receiver transmitters. So we had to come up with a solution. So there might be many motivations, arguments, whatever, rationals to go. Yeah, like this is the idea. I was so irritated by it for security reasons. Yeah, and coverage is a good one. Yeah. And they use satellite-based information. They use satellites to pass on in Africa.
What Michael said, so there is a certain message set supported, so no really complex messages are exchanged, standard ones. We enlarged our message set last year, so we even increased the numbers of exchange messages. So this is a key message.
Especially the rate of climb and descent, that increased the usage a lot. Because before we could only issue climb to level or descent to level, and now we climb to level 1500 or more.
Yeah.
And this is really beneficial because this is
More correct.
very often used and needed to be used. So.
Some more regarding speed.
Speed for the inbound sequence, for some big hubs like Munich and Frankfurt. A lot of them, the lower airspace wants to have speed control, a couple of mileage and speed. And this we can fulfill with this command.
And the future is going into ADC, which is also a component of the CPDLC. So to get the trajectory out of the cockpit. So considering the weight of the aircraft, for example, their flight mode, their cost index, so everything would be then shared with the ATC side. So what you have seen downstairs, the trajectory, would then come from the aircraft. So it's not calculated by a database. It would exactly know what the aircraft has in the flight management system. And then talking about time-based control, I know that you are interested. We know that from London, for example. So with ADSC, you would be able to click on a certain point and say, okay, not earlier than 45 past 1. And then you would send that to the aircraft, and the aircraft would then adjust the speed accordingly to be at that point at 1:45 p.m. So that is roughly the idea behind. So the new airframes from Airbus, they are all supporting that already. So the data is available. Still mandatory, it will be in a couple of years, not before. And of course the ground systems have to be enabled somehow to support that kind of data, but we have already our ideas how to use this data set to exchange it actually with our trajectories, to have that run from the aircraft. And of course it will bring the next step for having more accurate data in the end.
Real-time data.
Real-time data, correct. Because the weight, of course, is something we don't know.
Yeah.
We don't know if 250 people are flying to Vietnam today or only 50 people inside. You know, you don't know it. But then you know.
On the weekend I had a cargo flight coming from Bahrain to Brussels, and then he said, okay, please may I go down because I'm still too heavy to land. After 6 hours flying time. So you can imagine why? Because he had fuel for going and returning. Because fuel is much cheaper in the Middle East than here. And how should you know this? As a controller, you sit there and you say, okay, 7.6, I expect him to proceed more or less like this. But no, it wasn't. He said, okay, no, I need to go down because otherwise I'm too heavy.
So you can like assess the performance, assess like the clearance that you give to the aircraft based on their performance, right?
Correct.
But then
For
on the
example,
other,
if you would take that data and integrate in your conflict tools, for example, you might even trigger that tactical window that shows you some problems in the climb. Maybe it will show you less because you know that the flight will constantly climb 1500 feet per minute or greater. So I don't have to issue that because I know from the aircraft it will do 1500. So that flight 5 minutes away will never be affected. So this is the direction in which we are moving.
the problem with it is, even if you have correct data, then there's still a human being in the cockpit. And this, there's a discrepancy between maybe Western world and Eastern world. Because in Western world, the pilot training, a lot of things are done manually. So right after takeoff, if you have a Lufthansa pilot, for example, he turns in the cockpit many things. You know, he wants to go faster, going faster than climb, go forward then climb, or whatever, for whatever reasons. You know, they are supporting the hubs like Frankfurt and Munich. They have connecting passengers on board, so they need to go as fast as possible to that destination.
Yeah.
And you don't know this. And ADSC cannot tell you because ADSC doesn't know it as well from the beginning, because the flight plan was filed by office, broadcast to the airplane. But then the pilot steps in and says, okay, no, I have this restriction, that restriction. We change everything. We go lower altitude, faster speed. And on the other side, he says, okay, in the evening, oh, no, I still have another flight. I don't have Friday evening. So
What?
I have not end of the shift. So we can fly slower, save some kind of fuel. And this you don't know before.
So it is a way
Even
for,
if you have data, you cannot rely 100% on the data issued. So you have to make the second component, like the human being in the cockpit, is still a factor which you
still have to apply some buffers. That is for sure.
yeah.
That is for sure. But you also get an indication in the ADSC data if the flight is actually managed manually by the pilot or automated. So you still get that piece of information as well. So and maybe then you can adjust your buffers, you know, so more
For example,
reliable.
Emirates pilot will always fulfill the plan. That's his goal. Emirates pilot won't act individually. He will fly that one, that performance that is in the plane, supported by the office. This is a task he will do. He will never change something because he is trained in a different way. They have the obligation for fulfilling the plan, and that's it. At the Western world, like Lufthansa or whatever, they have some additional constraints or whatever. It's a different philosophy. So you have to manage both sides.
So it is the reason why we define the flight flow information environment coordinate, FICI, MMIC.
Wonderful. I do remember that we agreed on some questions you wanted to raise today, and I know that Lee took all the questions. Yeah, you documented them. I'm not sure whether you have it. Do you remember?
Yeah.
Maybe just to help you out, there was one thing dealing with human factors considerations. What was your experience in terms of change management, maybe, when you introduced all this new stuff, functionalities, methodology, procedures? Was it a big issue?
Sometimes when we introduce new functions in ICAS 1, we make sure that the controller can also use the old version. So that's the new function is an add-on, which makes the system better. But sometimes the controller is also able to just not use it. And therefore we hope, and this is our experience, in the beginning the controller says, no, I don't want to change. I don't want to have something new. And then you have the new function and maybe 20-30% will use it. And the other people say, no, I don't want it, but they look and they see, another guy is using it, maybe I try it out for myself. And then everybody sees it's good, it's better than the old version. It's an improvement. And then after some months, everybody uses it, maybe except of 1-2% or so, and then we know, okay, we did a good task, the HMI is good, and everybody will use it. That's our way, or what I told somebody of you before, I don't know who it was, and we changed from the strip system to Favorit. There were quite a few controllers saying, no, I don't want to change. I want to keep the strips, this is unsafe, the new system. But after 1 week, when everybody who worked at least for 5 days with the new system, stripless, everybody says, great, much better than the old one. You had no problems.
And one of the big benefits from a trajectory-based system is that the prediction is much, much better than before. So before, when we had this script-based system, people worked until the age of 50, then retired. If he got 52 before retirement, it was a good guy. And nowadays, people work until 57, and they are still alive. But before, the life from the old controllers was very limited, the age at the end. Because they, with the scripts, sometimes you're having 2 or 3 scripts in the bank, but then suddenly 20 scripts were falling down, and all traffic was coming. And nowadays, with the prediction, with the coloring, you see 20 minutes in advance what is coming to your sector. And you can prepare, you can adjust. You can adjust your working style, for example. If you're really, really busy, and you're okay, you work more or less standard, then it will work one by one, you issue the clearances, and then it's gone. Okay, you say, okay, it was exhausting, but nothing happened. And before, it was like a sudden flash, and then it was gone again, and then it was coming again, and you had no idea when it's coming again. You were always sitting there and were waiting for the big rush to come, and then it was coming, and they said, oh my gosh.
I think that